All right, so this is the name of the talk is basically introducing no-ops into your development culture such that you can hopefully remove some of the bottlenecks. All right, so to kind of start out with, I think it's pretty obvious I'm not Finnish. So I'm from the United States. I'm from that company called Dev9. We were acquired roughly in October here. As a part of that, a part of the partnership we have both from the new acquired company and into Nortal, I moved over here, so I'm now in Europe, and I've been here for about 4 weeks. And I don't know what everybody complains about the weather. It seems really awesome to me. So just a couple real quick, brief things. I've been kind of in the development space for 25 some years, done everything from device drivers to architectural work, all sorts of fun technology. I jump all over the place. One point in time I did front-end development, so just a pretty wide breadth of knowledge. I started working on Google in 2008. I was a part of the original Google App Engine beta. And as a result of that, as a search that I've been looking for my entire career, I've been really looking for a way that developers can really just focus on the code and then be able to turn around a fast business value as quickly as possible. So I was heavily interested in Cloud Foundry, which was with AppFog, and very interested in Google App Engine. And since then, largely what we've been building for customers over the last several years has been kind of a corporate PaaS, if you can kind of think of it that way. So PaaS has kind of a negative connotation sometimes, as in you lose your control. But when you build it with your own tools and you build your own principles into it, then it becomes your lock-in, and it's not nearly as challenging. So a lot of the talk will kind of cover around those. Outside of that, just to say I'm not just a developer, I'm a home brewer, so afterwards, swing by, grab a beer, let's chat. So I do all sorts of things. All right, so what do I want to get out of the talk today? What I'm hoping to be able to convey is that we have bottlenecks that are in software. If you're a developer, you know this immediately. There's many times you've said, there's the go compile, run and get a cup of coffee, come back, 20 minutes later and say, oh crap, that didn't work, and then recompile and go get another cup of coffee. So I'm going to talk why they exist. Some of them are there on purpose. And I'm going to get through this concept called no-ops. And I should probably say this right now. No-ops doesn't mean no operations. It really means just like NoSQL doesn't mean NoSQL. It means that it's not only. So what we're trying to do is we're actually moving the operations into a different space. And we're changing the responsibilities that exist in the development of software. And hopefully at the end of this, I'm hoping to be able to show where you can start baking in governance into this process such that you can reduce your risk overall when you have full mastery of the delivery of your software. So to kind of start out, I'm going to baseline and get us back to a spot where all of us are probably, if you're not here now, you have been there more recently. We're going to talk kind of modern software delivery, and at this point, it's largely not cloud related. Oh, and I should probably, before I get too far, at the very top up here, there's a URL. You can go to that URL, ask questions, and they will pop up on my screen. So inevitably, when you say, hey, you have questions, and everybody's passing a mic around, this makes it a little bit easier. So feel free to type them in. Anything, you can thumbs up, thumbs down other people's questions as well. Okay, so to break it up, for the criterion in which I try to say where do these bottlenecks come, it doesn't mean this is an exhaustive list, but it at least gives us some sort of framework to be able to categorize the bottlenecks. So on standard software delivery or service delivery, I'm going to assess this for procurement purposes, development. So procurement is basically acquisition of the infrastructure and requirements for the service delivery. Development is actually writing the code. Testing, which is ensuring that the functionality works as desired. Deployment, managing the versions of the software in an environment where your where your end customers will be able to use it. And then security, for making sure that you're not having improper use of the software or the data that you're working on. And then quickly following that, I'm going to jump into organizational patterns that will help, that highlight bottlenecks within your own application, within your own delivery teams. So in the service delivery, first we'll talk about infrastructure procurement. If you starting out brand new, even if you have a data center already, and you know that you have a brand new feature that's going to come out, a brand new service, first thing you have to do is say, can my data center handle this? And so you end up sitting down, you have nice long meetings where you say, what do we expect from a feature set? You do long projections and hopes and goals as to what that feature is going to be developed into. You think about how much capacity you're going to need. You do a ton of work. And then you eventually hand that over to a procurement team and you say, guys, go get me that equipment, get that set up in our data center. From there, eventually it gets built, put onto a boat. As we generally say in the States, a slow boat from China, and oftentimes it is. So, and once it arrives at the data center, then it's rack and stack. You're pushing into blades, you're hooking everything up, and some people are more proficient than others. And eventually at the very end, you get down to like, hey, here's your data center. Or so here's your new system. And that could be anywhere between months, oftentimes it's usually months for this to happen. And so inherently you have quite a few bottlenecks that are in place in there. Okay, now I have my new environment. I'll start developing code. Developers, in traditional methods, if you're using waterfall, or as I'm even finding now, most of the time, even in an agile development, there's still quite a bit of isolation. It's not very common that you find teams that will, or companies that have true self-organized teams that help actually solve every aspect of it. So development is still often done in isolation, and ops is usually very at the far end. They're not even included. So you're building your application like, this is the coolest thing ever. And you quickly realize that you are just doing nothing but consuming massive amounts of CPU. You won't discover that till much later. So that building in isolation is overall for the solution still a very big bottleneck that happens. Often when you're done working, or when you are working, you are fairly disconnected for the rest of the organization. And remote teams are even more. The further you push them away, the less likely they're going to know about the QA process. The less likely they're going to know about even the procurement of the system. They're just given an endpoint and some credentials and they run. So that in itself becomes a fairly large bottleneck. And of course, the last one is shifting the responsibility. Every developer has probably done this at one point in time, said, whatever, QA will find it if there's a bug. Or you'll do the complete opposite and be like, haha, I'm so good, they'll never find anything. And then when they do, you get frustrated. So now QA picks it up, says, okay, it's our turn to make sure it's in there. And at this point, it's almost adversarial because QA is like, I'm going to better the development team. I'm going to find these. And so they will do everything they can. They operate in isolation. They're even further isolated from how the system works. They know what it needs to do from a functional perspective, written in documentation or from the business owners, but not how it's actually put together. And so in that isolation inherently creates a fairly large bottleneck because the context switch in order to understand how to get the application built in an environment, how to get data, how to test it, that takes a lot of time. And so it's a further distance away. Often, I don't need to show our hands, but I'm sure everybody is aware of what's called either a gold build or a production freeze. It's where you're doing functionality for a long period of time and you haven't gone out live and the product owner is like, okay, we're at a point, do not change anything. So no code's put in there. That inherently is a bottleneck right there. Let's see, merges. I did put this up here. It is more common than I thought. We'll get into branching strategies in a little bit here when we get into the solution. But for branching strategies in particular, if you have really awkward or really difficult and complex branching strategies, then you will end up cherry picking commits, or you'll end up with strategies where you're making changes on a much higher up branch and then have to merge that to multiple different places. And that creates, hopefully we can edit this out later, that creates a term that we call the merge bitch. And that's somebody who does nothing in the entire day but merge code. And that right there is a huge bottleneck. All right, so QA is done. They say everything works great. Now, next line, we pass it to operations. Operations, again, operates in isolation. Operations is often maybe it's different here, but everywhere else I've been in the world, operations tends to be a different cultural aspect within the company. Developers have one mindset. Operations tend to be slightly different. They have their own culture that they build within. And so as a result, we create these barriers that happen between them. And at this point now, they're most likely a third deviation from where the product was actually designed. And so, again, context switches are major here. So a lot of the information, a lot of the bottlenecks that get created also is that because they don't understand the nature of the software, they understand the systems and how they operate. That's what they're focusing on. and the connectivity between them from a tactical network perspective, but not from a logical perspective. We ended up creating quite a few bottlenecks there and how their systems communicate. At the very end, you can talk about security. So operations has it. They're focusing on making sure things are stable, and security gets it. So I will say that security is one, and when I say that, okay, security team is one of the only two teams, I think, in any deployment that can actually halt it. So first you have the legal team. At any point in time, 6 to 8 month long release, legal comes in and says, that's illegal to do, everything stops, everybody goes home. The other one is the security team. Hey, we have a security problem, everybody goes home. Other than that, generally it takes a lot of consensus for them to actually stop, for your company to stop a build from going out. So security is very important and should be baked in very early. So we create a bottleneck by having them be towards the very end or one of the last thought of elements from the development perspective. I put up there certificates and installation and lifecycle, and that's particularly because in a cloud environment we have different options for that now. But certificates, it's not uncommon to see a 3 or 4 year old certificate in a production environment. That would be a cert for every single thing they have, so it's not uncommon. So if I want to go ahead and do a little bit of a summary on these and where these are set up. When we're looking at provisioning, we're looking at months in a traditional world. When we're developing features, it's anywhere between weeks to months, depending on the type of development team that you're with or the type of organization you're working with. Quality assurance can, again, be days to months, depending on the types of tools and process you have, but inevitably it's a fairly long cycle. And then product deployment, I put down minutes to hours. Minutes are really, really unrealistic for most traditional software development. Hours and possibly even days. I do remember at one point in time, and this is where I started my crusade to say things have to be better. I remember on a really long launch once, I was, it started at 10 o'clock at night, and we had food, and it was all catered, and it was fun for about the first 2 hours. And then you realize it's midnight, and you're kind of tired. And so got to about 3 a.m. or 4, and I still hadn't been called up on the checklist. So I'll just lay down. So I lay down, and then not more than an hour later, I kept hearing Mike, Mike, Mike on the phone speaker. I'm like, all right, I wake up, get out from under my desk. I'm like, what's going on? I check my one thing, and then crawl back under my desk. Sure enough, comes around 7 a.m., and we had a critical error, and they rolled back everything. So when we say hours, we could be talking like partial parts of days that deployments could happen. And so those are some pretty bad deployments. The last one, of course, is security. I've seen security pulled in at the very end, and then without the upfront knowledge that these new features or functionality is going out, I've seen security teams just flat out halt an entire 6-month project and to say, we're not doing this, and it's a huge waste of time and effort. So how does a lot of this end up coming about? Why do they have these different silos within the teams and the organization? The true answer is we do it to ourselves. And so what happens often is we end up with matrix organizations, and a matrixed organization means that we have developers who are in the development team, we have operations who are in an operation team, QA, et cetera. And in a waterfall method, this was set up in a way that was efficient because you got your pile of work, you did your work, and you passed it down the line. Well, as we start to get more agile, or we start talking more about agile and really developing that in, now all of a sudden we start saying, well, let's put together a self-organizing team. And that self-organizing team, or the team that has everybody on it, right? Well, instead of saying let's actually realign them from an organizational perspective into these teams, what we end up doing is we saying, okay, well, these 5 developers from the development team are now on this project. This QA is from that one. This ops is from this person, from that team. And what that does is actually matrix our organization. And as a result of that, that does create quite a bit of, actually what I put up there, first one, lack of accountability is what ends up happening primarily out of that. Each person actually on the team reports to a different organization who has different goals. So those different goals are actually fairly they tend to compete with each other quite a bit. So when IT operations, IT organization teams, they want to make sure everything is absolutely stable as possible. They are often seen as a cost center to the organization. And so that puts you in a mindset already of saying, well, I'm already negative. And so operations has their mindset on how they want to make sure they don't, or they keep their component up. Delivery is kind of the opposite. Delivery likes to say, what value can we change? How quickly can we add new value to the business? In fact, everything that they embrace is through change. QA, their whole goal is to make sure that the quality goes out, and they're the last line of defense. And so they're going to be a lot more stringent about saying this, to the T. If you have a documentation, I'm sure you've all been there, it says X, dot, this, and if it doesn't do specifically that, even if it's in the spirit of it, QA will say that doesn't work. Their goals are different. And then security, their whole goal is to make sure you don't unintentionally use it. I have found most of the time security are not usually technically oriented individuals. They tend to be more business oriented, and they have degrees in mathematics and things, but they're not highly technical. And so how they fit into the rest of the system generally doesn't, it usually creates a fairly large bottleneck because they have a large barrier of knowledge, and they don't quite have everything. So all of that put together, what does it create? It creates a broken trust model. It creates quite a bit of rigidity in your business because everybody has a different goal on how they want to achieve it, and it's not oriented towards getting something out for the customer and playing along in a team fashion. Let's see. I don't know if you've heard of this term, but this creates the wall of confusion. So a wall of confusion happens between development and QA and actually it's a wall between everybody. When you build silos, you'll effectively end up building a little moat. And when you do that, it's very difficult to understand where everybody else is coming from. And the last piece it does, it creates what are called shadow ops. And this is actually kind of an intro into where we, even as Dev9, came from with creating using cloud. I got to a point where I remember we were building something for a client, and we were told it was going to be 3 months for an environment. I was like, well, I don't mind sitting and getting paid for nothing. And then I thought, no, actually, I don't like that at all. I'd rather actually be doing something and getting paid. So we found AWS, and they were first coming out, and they said, all right, let's check this out. We started building our entire infrastructure in AWS outside of the normal organization, and then went back to them and said, now look, we did this in 3 months. We built the entire feature, and not just did we wait and have that ready, it's all ready to go. And the business thought that was the coolest thing in the world. Ops was really pissed. So shadow ops is the term for that. Now, from an organizational perspective, the reason I'm talking about this is because of the bottlenecks. These are things we have to think about as both technologists, but also as we start advancing careers into more of the business side. We have to think about how we communicate within our organization and how that is going to reflect the way we design things. So Conway's Law is a really cool law. This came back in some of the 1950s, I want to say. And basically it says, organizations which design systems are constrained to produce designs which are the copies of the communication structures of these organizations. What this means is if you have a matrix organization, you're going to design a system such that it's going to mimic that exact same communication pattern. It's how humans work. We want to do something, you go to where your communication's at, you talk to those people, and you do your work from that. So that means that it's very important to think about the communication patterns in which we organize ourselves to be more efficient. So these are some fun little diagrams here. I think my favorite one is, you can kind of tell the Apple one who's in the middle there. So, and I like the Google one too. It's just like, well, how does that work? Well, everybody talks to everybody. It's just kind of a big jumbled mess. And then you can't quite tell it, but in Oracle here, that right there is the legal system. I was like, yeah, that's kind of accurate. All right, to kind of summarize where we've categorized these, we look at process, and a lot of the process in putting these together, we build in our own bottlenecks, and that is a bottleneck, becomes the bottleneck, a barrier. Centralized decision making, I didn't really hit it as heavily as I should, but when you have these silos built, you end up making decisions on behalf of other parts of the organization without their consent. As a developer, you should never do this, but if you have a loop of a loop of a loop and it just eats up a crap ton of CPU, you've now made a decision for the ops team. They now have to handle that crappy code that you wrote without knowing that you did that. And then we talked about the org structure, and the org structure obviously is pretty important. So some of the areas, this is a great segue kind of into some of the cloud development that I'm going to show, some of the solution to these bottlenecks that we've used at multiple companies. So development area, and that's something we're just generally strong at. We understand software development from principles of software development and frameworks, and whatnot, but you get into some of my favorite areas. So the builds will be pretty heavily focused on the build process here for the rest of the talk. That has a lot to do with, it's a little spoiler, it has a lot to do with making this all work. And then the DevSecOps, because if you have a really strong build process, DevSecOps is the addition of that. So I'll be highlighting those specifically. So. All right, so we'll go ahead and go in here and talk about the solution. So now the solution that I'm going to present to you guys, we've now built this for multiple companies, and as far as I know, they haven't reached out and said they're not happy. They've said many times that they are, so maybe after 6 months they're not, but at this point in time they're very happy. So as far as this recording is concerned, they're happy. All right, so again, I want to highlight that no ops. I keep using this. I don't want to, we in our industry tend to keep using terms that alienate other people, other groups, and it's not meant to do that. The term no ops actually came out in like 2008 or 2009 as just, was when a lot of the like cloud first and all the other terms started coming out. Somebody coined it as being no ops, and the idea of basically saying that you don't need operations. And that's not at all the reality. The reality of no ops, or the movement of that, is really you're shifting a lot of your effort and your responsibilities left. You're shifting them into the development space, and you're using software to replace the typical operations that or the activities that operations used to do. The value of an operations individual is significantly greater than running a bash script, once a day. Like, setting a timer to remind themselves to run a bash script. Slightly better when to do a cron job, but anyway, like that's not really strong value for those individuals. The term should be probably much closer to low ops or something along those. I don't know. That was my creative. I changed no to low. So, all right. So there are some requirements that you need in order to do this, and I think the next slide actually goes more in depth on it. But you need to have control over isolation and state. You need to use infrastructure as code. You need to have observable items, and you need to automate. Some really good to haves. Universal project consistency. One of the solutions we just recently built was designing an entire consistent platform between each of the different 22 teams. And so they all used similar tools, similar principles, and similar process. And as a result, we were able to reduce a lot of the operations efforts because we didn't have to context switch between all of them. Also, the developers were then able to start moving from one project to another because the barrier to entry on those projects was significantly lower. They didn't have to go memorize how is our infrastructure constructed and what build tools do we use and all that kind of stuff. So it made it a lot easier to work with. And then good to have public cloud. Reality is, to build this, you don't actually have to have a public cloud to build into. You do need APIs to have the mastery over the infrastructure, but you don't have to have a public cloud. It's a very, very, very good to have, though. It makes it a hell of a lot easier. And then the last one I want to mention is SRE. So if you haven't jumped on the bandwagon for SRE, there's a great book put out by Google called Site Reliability Engineering. It describes the method in which we are trying to now target and build software. It targets infrastructure from a top-down approach, from a software into infrastructure, not from infrastructure up into not ops up into infrastructure. So there are some pros and cons. There's quite a few pros for no ops. You actually do enable true self-service. This means as a developer, you can say, I need this dependency, and you just go put it in. You don't have to wait for anybody else. You don't need an OK. It really enables that. You reduce the blast radius of your mistakes. If you construct your system right, or the system I'm going to show you here in a moment, if you mess it up for your team, not for the entire organization. Not to say they're not dependencies that might cause that to go down, but you yourself own the responsibility of that. You're not going to drop a database that has 30 teams that are all using that same database. At least if you do your software right, you shouldn't. Some of the challenges, though, this isn't a panacea. This isn't every company can jump into this immediately. It does take a level of maturity to get to that, to become a no-ops. The technical know-how it's not the easiest thing in the world to do. I'm going to demonstrate a system here, and I think I saw earlier, it looks like the system's back up. And so their reliability is off. But anyway, I built it in a couple days. I built it with a lot of little loopholes and shortcuts because I don't want to stand up here while I wait for something to build, and I can only dance so much. And nobody wants to see that anyway, so I can just see it now in the video. It's like I hit a button and then it's like swap over, like a montage. All right. Other things to pay attention to that you have when you start moving to the no ops as well. It's kind of a con. It's not really a con. It's a make sure you pay attention to it. Regulatory compliance and security are cross-cutting concerns, meaning that they're going to apply everywhere. Those have to be brought in into the process in which you built your entire solution. So organizational changes. Now that you start looking at the no-ops, you're going to have a change in your developers and your operations accountabilities. So from a developer, you're now going to be directly responsible for the infrastructure of your project. Whatever your service is doing, that service is now encompasses the dependencies for that. Then it's your responsibility to work with the other teams that you need to have cross-cutting concerns. So like a queue is often owned by multiple different teams, and so having a queue, you have to then work with the other teams to say who owns what aspect of that and build it into software. So somebody ultimately at the end of the day has the code in a code base that they have to maintain, and that ensures your accountability for that. Code-related security, so not just you should be as a developer thinking about writing software in a secure fashion, thinking about how you're passing variables, how you're exposing elements, but in addition to that, making sure that you have static code analysis. You're trying to catch code as early, like vulnerable code as early as possible. With that is adding in dependency checkers. There's enough of them out there now, it should be no excuse at this point not to say, I'm building a container, does this have a known heartbleed bug in it or something like that? Now on the others, actually, and to complement that now is, as a developer, it's your responsibility now to start working with the operations team to supply them with the metrics and the observability to make sure that your system's going to be able to be handled by the operations. The operations team now will lose the requirement, or they'll lose the accountability of having to put together the infrastructure and to manage the infrastructure. That's no longer in their purview, at least not for all of it. However, they should go back and say, now in order to do that, the trade-off is I need to know how your system runs. I need to know what it means when something is critical, when something's at a warning, and so you need to supply those pieces of information to the ops team. Ops now takes a step up in the world. Rather than running just a whole bunch of scripts and keeping things going, their exposure is much higher. They need to start focusing on looking at security, looking at the reliability of the systems, thinking about the global resources. So global resources being things like your global networks. When you're in cloud and you set up VPCs or you set up your global networks, those need to be managed and maintained by somebody, so that the ops team will generally handle that out. And they'll also handle all of the development tools that are not provided by the cloud, so source code management sometimes, and kind of the continuous integration tooling. So for your application, as a developer, you do have some changes you're going to have to make or make sure are a part of each of your applications to be a part of this no-op solution. Service disposability, I'll go into each of these in a moment, so I'll just kind of cover it briefly, but service disposability, code management structure, this is critical. Versioning artifacts, CI/CD, and repeatable and predictable builds. Dev9, that was actually our tagline that we used to tell customers, that we make software that's predictable and transparent and repeatable. So if you have not heard of the 12-factor app, this is a great time to learn. You can go to 12factor.net, and the 12-factor app was originally designed back in Heroku, I think it's 2012, so it's been around for quite a few years now. And the idea is that there's 12 factors you put into an application. If you adhere to all of those, you now have a disposable service that can then be rerun anywhere, anytime. It also creates a series of interfaces that allow you to then externalize configuration or build or run it in other environments very easily. I like to think of my services when I finally build them, it's in a container or a VM or wherever, they're just a compute unit. It has an input, it's like a true mathematical function, an input with an expected output. To me, that's what a service should be. If I want it to operate as though it's a development environment, I just pass in different parameters to say, here's your new configuration that is a development, or here's a configuration that is production. I shouldn't have to change that instance at all, or that binary that I built. So I'm not going to run through all of them, but some of the more important ones. Code base, every single thing you do needs to be in code. The solution that I'll show here, every single bit of it, there's not a single manual click on any of it. Everything needs to be in code. So that way it documents your process, but it's also repeatable. Dependencies, declaring every dependency you have. So it's not, again, your operating system shouldn't be built up and you run your code on there and you have dependencies that are covered up. It creates a coupling, which means you can't transport your application anywhere. Couple one for the cloud. So the port binding on the top right there, you should not explicitly bind your port, your application to a specific port. A lot of legacy applications do this. I'm sure you've worked with them. You know, there's everything from I don't know, WebSphere and things like that. You have to be 8443 and 8446, and you cannot run the application without putting it on there. When you do that, that prohibits you from being able to move this into other environments and to other locations. When I start talking about Kubernetes, it would really mess up Kubernetes if you were explicitly tied to a port. All right, yeah, I think those are probably all the good ones on there. All right, so how many of you guys have heard of pets versus cattle? Awesome, good. This is one of my favorites, so I won't go too deep into it, but I love the idea that I've sat in rooms before, and we in Seattle, we have this huge island chain called the Orcas Islands, and it's 50 to 60 some islands, and they each have different names. And we're like, this is great. We'll start naming servers from the west to the east, and yeah, those kind of conversations. When you're in that, you're making pets. It means that your systems are no longer ephemeral. They're going to be very static, and you're going to keep them up. A lot of the negatives that come out of this are drift. That's the most difficult thing you have to fight against, is that drift. The more you do that, the less you have the ability to make high-level controls or have an operation control. So cattle on the other side, oddly enough, that's the only really good cattle picture, a cattle yard I could find. That was free. Maybe if I paid for it. Anyway, so cattle are built and designed specifically to be killed and eaten. So we think about our services the same way. If I'm starting to build containers and they're ephemeral, all it cares about is there's a version with that. And the moment that it's no longer needed, it dies and goes to the bit bucket in the sky. And so we need to start designing our systems to be more like cattle and much less like pets. So in a cloud-native world, we do have some more changes to our applications where you should no longer be dependent on operating systems. We should be focused on just the code base that you built, or the binary, and the tools that run that binary for you. Your systems should be predictable, and this goes back to that having the drift on your systems. If you have drift, they become unpredictable. If they're exactly the same and consistent across your entire platform, then they become predictable. We'll keep going down and see. Scaling, obviously auto scaled and elastically scaled, intelligent. Our systems need to be like that. So in order to make this happen, and I mentioned, I alluded to this earlier, this is, I think, where some of the most work needs to happen within an organization. Almost every client I've worked with over the last 5 years, rarely do they have a mastery over how they actually control their source code. So I'm going to introduce a couple different methods, whether you've heard of them or not. There's a term called Github Flow, and the concept here came out in, I don't know, late 2000s here. Concept is every single thing is delivered off a master. There are nothing not delivered off a master for your code base. You want to make a change, you can't commit directly to master. You create a feature branch, you do your work in it, you create a pull request, you merge it back in, and then you can go to production with it. It's pretty straightforward. Master is always something that you can deploy from. And then you get to what's called GitLab Flow. GitLab Flow now says, okay, well, we understand that there are some challenges that come with directly going off a master on every single commit. It's very easy to push out a piece of code that is meant for later on down the path or goes with a larger group. And so you can construct what's called GitLab Flow. And this is where you say, all right, well, we'll accept one extra branch. We'll call it a development branch, or maybe call it a sprint branch. And you make one change off of that, or say one branch off of that. You do feature branches off of your development branch, and at the end of your sprint, everything's merged back in. You merge it back down to master, and you still only go off of master. At no point do you deploy something to production that's not off the master. That does give you some flexibility to say, all right, let's go ahead and make those deployments come off of the development branch into a development environment, but those should never at any point in time ever make it into production. So then there's Gitflow. Gitflow was designed largely off of the systems in which we had built with Subversion, and they are incredibly complicated. I'm sure a lot of organizations still use this. The issues that come up from this is you end up, again, back with that merge bitch, the person who does nothing more than just merge code constantly. And that's just not a fun job to be in. And oftentimes that person who's doing the merges, they don't understand the code that's actually being merged. And so the concept of Git Flow is that you have a production environment, or every environment has a branch, and every release has a tag, and then you have a master that really doesn't do much. Everything is kind of merged up through the chains of your environments. If you have a bug fix that happens, say on QA, you fix it on QA, and then you merge that code back down in to your other environments. And so it's very complicated, and there's a lot of different bouncing around. So I personally, huge fan of GitHub Flow, and that's what I try to focus on. We have tools now that allow us to develop GitHub Flow and not actually push out early release of code using feature flags. So the next element that we have to get into here is continuous integration, continuous delivery. Everybody uses continuous integration. I haven't met a single, well, I can't say never, but it's really, really rare to run into a company who doesn't have continuous integration. The concept of continuous integration is I write code, somebody else write code. At some point in time, another system, you'll compile it and see if there's errors. You'll see if there's any bugs. It does not mean that you're actually producing a binary at the end, and it doesn't mean that you've automated the process out into an environment. It just means that you've combined everything together. The concept of continuous delivery then is to say, take a continuous integration environment and then say, let's make a known point in time that we have a release and we now have an artifact that we're going to be using. And from that, then we can then make a manual decision to say, let's go into an environment or let's go into a production environment. Oftentimes, a lot of my clients get to the point of continuous delivery. They don't want to do continuous deployment. The big difference on continuous deployment is you have what's called push on green. It's when you get done with your acceptance testing and your rigor, you automatically push it to production. And a lot of customers are still a little bit shaky about doing that, and it's because we as developers and we as operations folks have not built enough trust into that platform to allow them to say it's okay to go and go to production. So I'm going to briefly go over this because it's not super important, but I do want to highlight on a CI/CD pipeline, or the process they're generally called pipelines. You can start building these a lot like you would a manufacturing plant. In fact, it's really good to start thinking about your CI/CD pipelines as manufacturing. If you haven't read the book Phoenix Project, that is a fantastic book, and it really heavily hits on this concept, to the point where it overdoes it, which is good. We need a lot of effort on our CI/CD pipelines. So from us, our company, Dev9, was founded on the principles of continuous delivery. That was the starting line of like, well, let's build a company based on continuous delivery. And from that, we had to actually built a business plan and everything else. And I think we did good. We got bought, so we did something right. But as a result, we are highly opinionated on what CI/CD is. And so for us, we like to say that there are still two distinct phases on CI/CD. You're building and you're releasing a product, and then you're deploying that release somewhere. And I think those are two distinct phases. It doesn't mean that they're not lapping together. You don't have one kick off the other, but they're still distinct. So in a release pipeline, I've got my feature, you'll see my feature development here is set up. And you're doing your pull requests, your merges, your code reviews. It's important to note the code review on there because that's a part of that governance piece. And then you run through the entire pipeline, you get to the point, you say, all right, we're good for this, let's make a release. And at that point in time, you have a versioned binary or a versioned artifact of some sort that you know exactly what's in that product and it's never going to change. And that's important for that piece. Now, on the other side of it, you have the deployment. The deployment should be able to say, all right, given a version that I'm working with, I should have some configuration and some context information to provide together, and I should be able to deploy that somewhere into an environment. So that's the major reason why you have a distinction between the two. You can create tons of versions, but maybe you don't want to deploy all of them, or maybe you want to redeploy an old version. You should be able to marshal up the configuration that you want to put together, and then push that, with the context, push that into an environment. And so you can effectively roll back or make different changes. This is especially important when you're looking at fixing a bug in production that happened 2 or 3 releases previously. If you have individualized versions, you can go back, redeploy it into an ephemeral environment, do some testing on it, figure out where your bug is, and then fix it for the future. And some of the cool things I put in here, I did put down things like versioning your containers, but also like building your infrastructure. A lot of the time, this will actually involve building. In my demo here, which is now, so, I'm going to walk through what I'm going to do. So I'm going to do a live demo. So we'll see. I didn't sacrifice a chicken this morning, so, and I already know it's Bitbucket's down, so maybe I should have done that. I'll talk through like what I'm building here. All right, so to start out with, you won't see exactly as I have a little bit more code than this, but I'll just walk you through the progression of building a system that is going to be in a no-ops fashion. So initial project, I'm just using Java-based. You basically have source and you have your code. This shouldn't be groundbreaking at all. I do have one thing in here, a makefile. At one point in time, I went down the path. I'll just share this because it's useful. I went down the path of using makefiles to make an abstraction for the build tool that I was working on. Turns out you can just change the makefile, so it's not super useful. But in a system where you can inject a makefile in and you can say, here's the CI will only call these methods in the makefile, and at that point you can actually enforce consistency across all of your different builds by saying, I'm going to inject this in, I will only call these operations. You now have to serve your side of the interface by using your build tool to satisfy those stages. And someday, maybe if I would have put more effort, I could have done it. I just didn't. All right, so next piece is the CI/CD pipeline. I'm a big fan of declarative formats for CI/CD, and I think that it's absolutely required for using a no-ops process to have a declarative format. So declarative format means I go in, I say, what would I like my CI/CD to do in terms that are declaring what you would like it to do. The platform itself will pick them up and make those operations happen. And so in this example and the one I'm going to do, Bitbucket is what I'm using, but there's a ton of formats out there, or a ton of different build tools. GitLab is a fantastic system that we've been recently using. Everything from Circle CI, Jenkins, even Jenkins is pretty decent. One thing I will mention, and this is just kind of anecdotal to this, having the CI with your source code management, it tends to be a much better practice than trying to develop an organizationally large CI system in which you're developing it into. If you have it much closer, you tend to not run out of resources, and you also don't have a lot of backups for builds and wait times, and so those tend to be a little bit more efficient. Also, ThoughtWorks put out about a year and a half ago, on the tech radar, basically said they came to the same conclusion. They said, try not to build an organizational-wide CI system for resources purposes and coupling purposes. Oh yeah, I forgot to mention Docker. I mean, pretty much now Docker is, if you don't know what Docker is, grab a beer with me, I'll explain it. All right, next level that is a part of this. So, okay, you've got the mastery of the product. You've got the final artifact that you can build. You can deploy it to a Docker Hub compliant repository. Everything's great. Now, that artifact, maybe it needs to use a database or a queue or anything else, right? So now we have the concept of infrastructure as code. It allows me, again, to write a declarative format for my cloud provider, or from my whichever provider you use, generally cloud, will then go make that system for you. I personally like Terraform. I've been using it for a couple of years now, but there's a CloudFormation, there's a deployment manager, there's Code Builder, there's quite a few different systems out there that you could potentially use. A lot of the industry is shifting more into the Terraform at this point in time, which is why I reserved a spot on my laptop for HashiCorp, right there. Yeah, I have coveted space. I got a smaller laptop now, so. So I'll go through my solution. I'll actually show the Terraform for you. Some of it, I will tell you, I'm not going to run all of it because I did that earlier, and the database takes about 15 minutes to load up, and I don't really want to waste your guys' time with that. So I wanted to do like the baking show. You'd be like, oh, and here, and then pull out the new one. So that's kind of what I've done. All right, so here's the structure that we broke it down. So this is actually pretty critical to our system and our final solution for our customer, and this is how the no-ops really comes down and works. We ended up building essentially 4 different tiers of infrastructure for our client. And the reason we did this is because we created different isolation in the different layers of the application. So in the very top level is your global. In your global space, you should really be defining very, very high-level identity management and maybe high-level global networks, elastic IPs, potentially DNS, kind of depending on how your solution goes. It's not, this isn't declarative to say this is the only solution, but think of things that should pretty much never be changed. If you go in and you make a major change to a network, you could really screw up your entire organization in 5 minutes. So it's not a good idea. So you try to put that up there. Next one down is a segregation layer. We fought back and forth between business unit and segregation. The permutation tends to be better when you have your segregation at the top. So segregation for us is non-production, production. You could break it down into non-production or development tests, whatever. But again, I like to think dynamic. So non-production is not production. It's everything but that. So from that, I don't care. We could have 50 test environments or whatever. It doesn't matter. So then we come down to the business units. This is kind of optional depending on the size of your organization, but a business unit would be a division within your company that you want to have identity management isolated to, so that way you're not sharing identity management roles between different organizations. And then at the very end is the application. So these are the actual teams in which they're building their applications. Now, if you notice, I have the Git logo on all of those. That's in purpose. Every single one of those is a Git repository. Or at least a Git location. And you do that in order to maintain governance. So if I don't want anybody touching the global networks, they don't have access to that repo. There's nothing they can do to make those changes from there. You should back it up also by not exposing your console too much in your cloud provider, but it's basically essentially setting it up so that's one very coarse level of governance you bake in. And what we ended up doing for each of the different levels, we also ended up pushing and saying that nothing gets deployed to master, so nothing can change unless it goes through a pull request. And we put a minimum of 1 reviewer. At the two clients ago, we ended up having 3 reviewers. And so they really had to be stringent and make sure that the code was reviewed and approved by 3 different individuals. So that way, when you make a change, say I go in and I make a change that drops a database. Hopefully, more than one person views it and says, "Hey, Mike, you shouldn't do that." Unless you're like, "Do you really want to do that?" And the commit should say dropping the database. So this is an example of what one of the systems looks like, and there's a lot of gray because it was huge. But the idea, you can see that we have the top global level. Beneath that, we have a segregation level for host networks and stuff, then drops on down. And again, you can kind of pepper in and play with where you want to put your logging, your metrics, and the different types of ancillary observable tools based off of how much you want people at what level to see those. So we ended up putting we ended up having 2 separate non-production stack driver instance for logging and metrics, and then we had a production version as well. And so we locked down the production unless they needed it for short-term. You can grant them short-term access. So what I'm going to try and show is what's really in green here. Oh, that's weird. That didn't come out though. Oh, that's right. I forgot. I did a fancy thing. I was like, okay. So what we're going to try to do is I'm really going to try and show this is what I largely built, minus the folders. I didn't take all the time to do all the folders. All right, so now that we have infrastructure as code, you have 2 options. In the application itself, having the Terraform inside of the application I think is a really good idea. It allows me to, when I commit my code runs through the CI, and the code for my dependencies are in the application itself. And so it's much closer. It's a good rule to have that anything that happens close to the source code, so I keep my Terraform in there. I'll get to that in a minute. You'll actually see live code. So now the last piece here of all of this now, we're at the very end. We ended up using Kubernetes because it's a very simple system to work. Well, it's difficult to operate to start with. Once you get it, it's a lot more simple. As a developer, it should be very simplistic because you pretty much don't have to do anything if you set this up with the CI. So I'm not demonstrating blue-green deployments because I didn't have enough energy to do that for a day and a half. But I will largely try to show some of this. So. Helm is the package manager that we used for our Kubernetes, which allowed us to make an abstraction for the deployable YAML files that Kubernetes expects. It allows us to pass parameters into that. It makes it very simple and easy to work with. And so I will show that. So we'll see. So this is where I have to do a little bit of typing here. I feel like maybe I should get my beer. Let's see. So, yep, looks like Big Bucket's still having some issues, but we'll plow ahead anyway. So what I'm going to show is I'm going to show top-down, lay out the structures, and again, some of these you'll see I've run them, and I'm not going to run some of them. They take a little too long. From a top level, I have my global infrastructure set up here. Inside of there, just look at the source. It's not terribly complicated because at my global level, again, I don't want a lot of activity up there. I don't want to let churn. I want some real basics. So I have a Terraform folder. Inside of there, I set it up such that if I want to use modules, I can. Terraform has these concept of modules which give you some composability to your software, allows you to rerun individual units of infrastructure and start thinking of your infrastructure like you would software. And that's when you really start getting the dynamic element of of work, and that's where it's fun. So I'm not going to go to all the files, but I want to show this one, this main file. Maybe I do. There we go. My effectively going back to that list of the hierarchy, that map that I drew, my global, I want to build my next division level down. So this is my first level of separation here. I'm effectively building a module. This module is, come on, please work. We'll see. The module effectively is building inside of Google. There's a concept called a project, and that contains all of the resources for whatever you're building. So virtual machines, Kubernetes, networks, et cetera. It's all contained in a project. Resource groups and accounts are synonymous with this in the different AWS and GCP. So I'm effectively building a storage bucket because in Terraform, you create state files, and these state files then represent what's actually in production, or say in the environment that you build. And so if I do that on my local laptop and somebody else runs it, they might overlap and overrun mine, and so I have to be able to expose that. And so the way Terraform does that is they like to use S3 compliant buckets. So Google's version of that is just a storage bucket. So I set this up to say, when I build all this, it's going to go into this folder, and then I look at my folder services to say, what services do I want to make available for all of the project. So now, go back into here, talk about how this is built. So I'm not going to make changes on here, on this one, because I don't want to blow everything else away at this moment. But in my master branch here, I'll just go into one of these. And so again, when I mentioned that I like to see Terraform run and all of my infrastructure run in a continuous integration environment, or CI, I actually do exactly that. So you'll see here that I do some initialization stuff, but here's my actual build. Terraform validate, it's the command to say, is my Terraform files consistent? Do I have any error? That's linting, basically. Then I look at Terraform plan. Plan should say, what am I trying to do? In this case here, nothing happened there. And then in my change, I'm actually adding a service to my project, and a service in Google's world is saying it's an API that's available. So this didn't actually do a whole lot of stuff, but we're making one change, one destroy. And then, did I actually did run this one, so there you go. Here's Terraform apply, and it runs through the same thing and basically says, we made one change. So now it's cool that my infrastructure, or my CI is making all the changes for me, and it runs through the normal process of a a pull request, and we have reviewers. For demonstration purposes, I am my own reviewer. I would not suggest that for production. That would just be awkward to give everybody accounts and have them review my code. All right, so I'm going to give an example here of this middle tier, and on this tier, I'm actually going to make a change and demonstrate how this runs through. So the middle tier now is that division. So I've picked up the division, and I've decided I'm going to run code on there. I'm going to do this the full-on old-fashioned way, so bear with me as I type. Let's see which one's which. I put these in different repo or different windows, so that way it doesn't look like it's all in one file. All right, so say for example here, I want to add a bucket. I'm just going to do something super innocuous because honestly I don't want to wait forever at this point, but I'm going to create a bucket. So I'm creating a brand new storage bucket. I'm going to call it the finish bucket for a no ops presentation. I'm going to pass in a variable of where I want it to be located at. This is located in the project. This is a variable I'm passing in. I won't go into the nuances of how Terraform is done, but there's a great book called the Terraform book. It's written by James Turnbull. He's a operations guy who's been around in the industry for a very long time. I highly suggest picking that book up. It takes 4 to 8 hours, and by the completion of that, you should be nearly a master at Terraform. It's pretty lightweight and thin. All right, so I'm going to go ahead and do that, and if I'm doing this right, get my terminal up here, maybe. Okay. Call that. Make sure I have it on here. So I'll go and push this up. So now the CI is going to say, all right, we have some new code. And you see, now it's picked it up. It's automatically started running it. And in my version, what I'm doing is I'm not running the Terraform first. What I'm going to do is, because it's on a feature branch, I'm going to run it up to the validation point. I'm going to, or sort of the plan point. It's going to print out what it should be doing. There's debates on how you might want to do this. You can use S3 buckets or other pieces to take that state plan and then rerun it on production to make sure you validation. I didn't go all the way into that depth, but it's a good suggestion to not just have the plan run and then who knows how much longer until you actually have another merge and run. So it's a good idea to have plans saved externally. In mine, I'm not able to do that, or we didn't want to. And it's probably also fair to say that I made other corners. I've got, like I'm building a storage bucket at a division level for no particular reason, then it's faster. So not high material value. I don't know, like it says it's experiencing problems, but to tell you the truth, that was pretty fast. All right, so here's the plan. It's gonna start running, and now this is gonna come back and tell me what it is it's doing. And nice thing is it says we're building a bucket. And I was like, good, that's all we wanted to do. All right, so now, again, it looks a little laborious because I'm a single person on a single team, so maybe that's a qualification also to say that this is not something you want to do if you're a one-man shop. It's extra work you probably don't need to build in. But if you start getting 2 or more teams, it's not a bad idea to start thinking about this. When you get into the repetition of it, it's really not that complicated. So again, this would simulate the idea that I'm working on a team and I've submitted a pull request. If you set up your configuration appropriately in your CI, you yourself shouldn't be able to approve your own code. Somebody else will have to look at it. In this world, I'm not doing that, so I'm like, yay, I uncommented stuff. Very simple. I don't think it's painful. Go ahead and merge it, and now upon merge, now it's going back to master. When it's in master, now I allow, in my CI, I allow that bucket to actually be run, or that Terraform to be run. So I'll go back here and let this start. Now, if I can catch it before, I should have done this before. Just take my word that this is the division we're working on. Crap, I should have proved this ahead of time. I guess you guys trust me enough, hopefully. All right, it's loading up. This is the buckets right now. Hey, there's no buckets, good. So now, we'll go here, let this run. This will take a minute or so. I'm not going to waste your guys' time while I do that. I'm going to go ahead and show the next portion of this, and we'll come back to it. So then the next level down is my code. And so if I go to my source and I look at this, this is synonymous with anything you want to build. I did call it the dead simple hello world because I realistically wanted to call it, and I didn't want to put any effort into it. So it is dead simple. You'll see here, I got my source, I've got my Bitbucket pipelines, I got my Docker file, I got my Terraform. This is my dependency, so I'll go and go in here and show it. This application requires a database, so I'm creating a database instance. I'm creating the actual database, I'm creating a user, and then I have random numbers because you don't want conflicts. And again, if it's ephemeral and it's not a pet, and you have things ephemeral to system, it doesn't matter what the name is. Humans kind of need to read some of it, so the name prefix is at the very end. All right, so go back to my source. The code really doesn't do a whole lot. The other piece I wanted to show here while I'm waiting for the other is I created a Helm chart. And a Helm chart, again, if you're not familiar with what those are, Helm charts, it's a packaging system that you can use for Kubernetes. There are a lot of publicly available Helm charts out there if you want to install anything from Redis to databases to anything, basically. Almost every company that has a product has created Helm charts now. So it's divided out into your chart file basically defines what your actual product offering is. Values here are a whole bunch of literally just values. It's a YAML file that tells. So you can see my repository is this, and I want it to be a load balancer eventually, and all this other kind of fun jazz. Inside of that, the templates folder holds the actual templates. So if I want to make a Kubernetes service, you can kind of see roughly, just without even diving in too much, you can see it's the format of a service YAML file for Kubernetes with some parameters passed in. So I'm going to use that to make my deployment. All right, let's see. Good. Hey, it's been configured and it's been run. So let's go in here, do a refresh. That's where the demo gods are like, please. At least boot, at least reload. Yay, and there's our bucket. So you can see that happens, and just as easily you can go back and remove it as well. If I go back into that Terraform file and I comment out or I delete that, when I go back through the whole process, Terraform will remove that for me. So that's actually the danger you have to be careful, is that you can't just, it's not a forward once only change, it tries to maintain consistency. So now if I have this for a divisional level, everybody in the team would be able to use it. All right, so let's go back to here. I'm going to actually try to affect a change. I do want to describe this a little bit. So this is the method in which I'm now delivering. So on my individual team, I need to think about building the code and testing it and doing full test code coverage and all the other niceties of a pipeline. That all goes into here normally from, I put them down here at the bottom of the branches. I don't know, they're in here somewhere. And then I have a separate stage. Oh, here's my default. So here's where I do a lot of just niceties. So you see all I'm doing is Maven verify is a simple command. I'm checking, I'm building an image, and I'm pushing it up to the repository. At this point, it's doing nothing more than that. I don't want to do anything else other than have that. This would be a good point in time if you wanted to deploy it to a different environment, like a development environment for testing purposes. Not a bad idea. Another also awesome idea too, if you're using multiple different repositories, you can use a development repository and a production repository where you have extra checks to make sure that you're not ever pulling something into production from a different repository, from a development repository. It's a good idea as well. If you're using Google, Google does everything in the background with GCS buckets. You can set those GCS buckets to have a retention of 30 days, and so could thus keep your cost down on the images. Granted, it's super cheap anyway, but every little bit helps. Now, what I ended up doing here is I rather than have my master actually do the deployment, I have other things I want the master doing. I want it building and pushing, and what I wanted to do is I actually wanted to tag. Because what I want to do is I want to get to a point where one of the qualifications of this is that you have a binary that has a version on it that you can always go back to. So I'm going to tag my repository with a very specific release and commit number on that. And so then in order to make sure that these things are then coupled together, so I'm not just building it, releasing it, I'm going to kick off my deployment at the same time, I'm actually going to use a tag. I'm going to run it, anytime a tag comes out, I'm going to run a series of commands. And you'll see here at the very end, the last one is I'm running my Helm command to do my upgrade. So again, there's little checks and things you probably want to put in from a true production environment, but in general, that's the right concept. So let me go back to pipelines and dead simple app. So I know this is kind of boring, but let's do this. I'm just going to, again, I don't want you guys to watch me type. I've done too many demos where I've seen people do that and it sucks. All right, go here. Pull this guy up here. Let's see. See if I have anything on here. Okay, it's just this. Adding back in stuff. Okay. There. So go and push this back up. So again, you're doing whatever you're doing. Okay, looks like that went okay. So go back to here. Now we're going to end up seeing 3 different builds that happen as a result. The first one is just the CI concept. Is my code running? Is it functional on the feature branch? This should run your normal test and say, yeah, everything's good. It should fail if there's a automated test that fails, or anything else you have in your pipeline that should fail for whatever reason. Fast feedback. Should be pretty fast, so hopefully don't really want to. I should have cut out some of the things like building the image just for brevity's sake, but I didn't. Let's see, what else can I show while I'm waiting for this to. Maybe I can't. I guess in the meantime, if you guys, I don't know if you guys are used to VS Code. I've been using this now for about 1.5 years now. For Java development, still a little shaky. They don't have all the niceties that IntelliJ has, but for the fact that I'm using a Pixel book, it works great. So, all right, so there we go. So this, if you've used Maven, you should be familiar with this. Time out for beer. Sadly, this is actually how most of my actual development goes. It's after 5 o'clock in the afternoon, and I'm drinking a beer and coding. During the day, I have to do other stuff. All right, so everything's successful there. It's going to go ahead and create the image here and push that out. So knowing that that's happening and it's doing its thing and it better not fail, I'm going to go ahead and create a pull request for this and kick off the rest of the 2 cycles. So the next one is going to automatically start on the merge, and then once that the production image has been created, it tags the environment, tags the repo, and then the deployment should happen from there. So now before we do that, as this is doing all its fun jazz, I'm going to approve it. I'm going to go show you what the insight looks like, so you can see that it's going to change. This just takes too long. Good, it's kicked off. Okay, so now I'm in the I'm in my Google here. I'm going to go to my Kubernetes, look at my clusters. I had previously built this. Go to my cluster. And now from here, I'm just going to pull open, let's see, it's under services. I'm going to take, so the service is, I've created, I think it's just called Deb's darn simple, whatever, Dead Simple Web App. I'm going to open up the,
Hey, what was it?
Apollo something? Shoot. Yeah, I'm surprised this didn't happen before. All right, okay. Well, this didn't pop open my, okay. All right, let's try that again. All right, dead simple. It says, hello, Helsinki, hello, Finland. Again, it's dead simple. All right, so let's go back to our code. Let's see where we're at, and I'll either go a little bit more into, okay, pipelines. Okay, so it's in progress right now of building the master. It's doing the Docker build and Docker push, which is great. Maybe. Yeah, there's optimization points that can happen at all sorts of points in here with multi-layered Docker files and stuff like that. Come on. So I guess in the meantime here, I'll kind of show a little bit about this. If you're not familiar with Kubernetes, it's a fantastic system that allows you to orchestrate the containers, and allows you to it uses compositions of pods, which is almost synonymous with a container. You can have multiple containers in a pod, but it's the lowest level granular piece. And then Kubernetes allows you to marshal up those using labels to kind of put them into different groups. And so you can have groups of pods working together and using in methods that are called replication controllers that allows you to say, no matter what, at all points in time, I have X number of these pods that are available. The system will make sure that always happens. And so it builds in a lot of what you kind of call first tier problems. So if you're ever used to calling your IT department and say, hey, my system's down, the first thing I'm going to say, let me go reboot it. Well, if your system does that for you automatically because it's paying attention to readiness and liveness probes, then you've already eliminated that first call, and they can immediately start diving into what could that problem really end up being. All right, so right now it should be gone. Yay, it's been done. So now, whoops. Back in they should be running. Should be running. Or did it already run? Nope, not yet. Oh wait, am I on the right one? Yeah, dead simple. There it goes. Oh no, it already ran. All right, it already ran. So again, we walked down through here. I did the Helm upgrade, and it started all those things up. You'll see that it's creating the terminated the old one, creating the new one. So now if we go back here, here's where the proof point actually happens. Yay! Now we have some hockey players from Finland. So if you get to know me more, I love hockey. So in fact, I even bought a jersey. It's sitting over there. Like, I love hockey. So I just put down a couple of them, but that's pulling from the database that I had created. So this is not really useful in a production environment, but it should at least demonstrate the end-to-end capabilities of putting this all into a CI and running it from beginning to end. So with that, I'm going to go back to my presentation, and I can relax. My demo's done. Yeah, and it worked. All right, so we can move that over. All right. Okay, so I'm nearly done with the rest of this. Thank you. All right, so then the last bit we have to think about here that I didn't include in my demo here is security. We have security in layers. As you're building your software, it should be everything from static code analysis, dependency checking, should be using ZA proxy or something similar. There's different Veracode and a couple other products out there that will do penetration testing and variability testing against your system. You also have the opportunity as you're building infrastructure to start using things like Gauntlet's a great example, or BDD security. There are different platforms and frameworks that you can use in order to then go check or create tests that you know are going to be against your code. So if you know that you need to have port, 1590 for some arbitrary number, that one has to be available, you can write a test that says is everything else closed, nmap it and say is everything closed except for 1590. And if it's not open, or if you have multiple other open, fail your test, and then you immediately know that you have a potential security vulnerability. So these can be put in place to kind of help you with that. So in summary, I'll run through these here to kind of summarize everything I've been talking about. So from a procurement perspective, when we go into a no-ops situation, we're using a cloud, we no longer have to worry about requests from procurement. They don't have to go buy anything. They might have to sign off on a billing account, but other than that, they don't actually have to be involved with the rest of it. No longer do you have to rack and stack either, and I will tell you most of the ops people are actually okay with that. So we should be running, rather than from months, we should be down to minutes. And so we've reduced that bottleneck significantly. From a development perspective, if we are operating in this fashion where everybody has a piece of this, you have your test cases, you have your automation, everything is built into that delivery pipeline, you should no longer be building in isolation. You should be working with the rest of your team. The remote teams will be working on the same code bases and the same components you're working on. They're going to see the exact same infrastructure. You're now intimately familiar with the infrastructure you're required to work with, and so you shouldn't be working in isolation from that. And you're also no longer shifting this over to QA. You're now responsible more for the QA of your aspect because you have more control, and so you're accountable for it. So we should be going from a month, maybe even weeks. I put days, but to tell you the truth, you should probably be getting down to hours. There's no reason why, if you have all of your risk taken out of your process, out of your solution, because you were developing small iterative little approaches and you've built all this testing into it, there's no reason you shouldn't be able to produce multiple different deployments a day. Testing, again, isolation of the testing environment is no longer there. You're able to take these environments and build them at will. And so if you want to do ad hoc testing off to the side and say, I don't really know how this works, build yourself an environment. With a few runs of a CI, you can have an entire environment just to yourself, just for the period of time you need it. You no longer have this idea of gold builds. We're no longer building to a point. You should be releasing frequently and using either Github Flow or GitLab Flow in order to control what goes out. You shouldn't ever have to stop. Part of this from an organizational perspective is the mindset to make sure you have that. Code merges, again, we shouldn't be, if you ever use the word cherry pick, you're doing it wrong. So it's not that the functionality doesn't work, but you shouldn't ever have to use that. And then QA shouldn't be passing that to the operations. And again, we should be moving that testing back into the same cycle of the rest of our development. From deploying, again, we're operating all this in. I just demonstrated how easy it was to go from a change, operating in. At no point in time did I have to go in and run scripts. Whoa, that was weird. I all of a sudden heard myself not out there. I heard it in my head. That was weird. Sorry. Okay, yeah, so we no longer have that out in the outside. It's now inside of our system for the deployments. Let's see, we'll get down to coordination with other teams. And then security, again, I had mentioned we can start bringing that security back into our pipeline. And so again, we should be back to deployment, should be minutes. In fact, my super simple, dead simple deployment was a minute. So I put minutes because nobody deploys something that simple. All right, and then finally for security, let's bring that feedback in as early as possible. Let's get those deployments back in the CI/CD pipeline. Let's keep that away. We don't want that team to be the person that says you can't go live, or if they do that, it's not at the end of the cycle. It should be at the very, very beginning of the feature development you're working on. I didn't mention this, but I wanted to allude to this, and I just realized I forgot to talk about it. The idea also, when you have your systems and you're able to automate this, now you can start using different products out there that allow you to insert certifications and store secrets externally from your applications. So you no longer have to have one certification, or sorry, one cert that you push into a system and then hope that it stays there forever. Those systems are going to be dying consistently. Rather than going back to your system and saying, okay, well, I need to update my code, I'm going to push new code into your container or into your VM, just rebuild the whole thing from scratch. And so you have a problem with it, make a change, push all of the pipeline. The more frequently you can practice that, the better. Now, as a result, that means your certs now have to kind of have a little bit of a ephemeral nature to them as well. There's a product called Let's Encrypt, and most importantly, they came out with a protocol called Acme, and it allows you to have automation of the recreation of these certifications or certs, and you can do from internally. So you can then pass those into all of your load balancers and any other system that needs a cert, and you can actually rotate them much faster. It allows you to have a much better handle on security. All right, so basically, all I want to say here, I'm not going to read the whole slide, but the idea is that with this process now, when you build this in and you are dedicated to running this process with you, your team, and your organization, you should be getting all of your delivery should be come down to minutes and hours, which is what you actually want from a developer rather than sitting. I mean, drinking coffee is awesome, but you should do that while you're typing, so rather than getting up and doing it. So I realize that might actually have a kind of a negative thing. I think people like to talk, so. So I do have some questions, and it looks like things have been added here. So I will show my favorite one that popped up. It's my favorite Finnish beer. I would say maybe lager-based. I really like Karu. I think it's pretty cool. I just like the logo more than anything. So can we get the slides? Yes, I will absolutely get the slides up there. I'll put them out on the meetup. Okay. How about security and auditability when using CI/CD that is distributed to application repos? How do you ensure the delivery pipeline is securely done by everyone? So this, again, we can use software for this, and what we ended up doing for one of the companies is that we actually have gate checks when they go to make their commits. We have post-commit hooks that are into the CI, then allow us to then say, does this have the files that we want? We're not doing, at that point, it's enough to really just, the fear of having it checked by somebody is probably way more powerful than actually checking it. And so the fact that we have the list of files that we expect them to be, that's enough for the teams to actually do it. We have to give them some accountability. But that's probably the closest we did. You could go much further with that because you obviously have control. We just drew the line somewhere. Hopefully that answered the question. Let's see, what does it say? When Terraform difference there. Okay, if I can kind of summarize what this is trying to say is basically how do you build in your governance with Terraform? So I'm showing the open source version of Terraform, which if you want any type of governance, it needs to be mostly human driven or business driven. That's me as a reviewer saying, you know what, that doesn't make sense. You probably don't need a Kubernetes cluster with 25 nodes. You're running a single container. So that's for me to catch. Now, if you start using Terraform, the enterprise version of Terraform, it does actually have a policy manager in it. And so you can actually write declarative code that says this can never be run if it doesn't hit these policies. So like a cluster can never be a certain size, or you can't deploy after a certain time, or there's all sorts of things you can bake into it, and they're constantly putting out new feature functionality for that as well. I didn't specifically highlight it, but let's see. I love this one, and the answer is I don't really have a great answer for this. I will say, again, different products have different capabilities. Google does right now have something that's called the DLP. It's an API that allows you to stream data into a system, and it will automatically redact data based off of different settings that you want to put in. I don't know of any other systems that is nearly as efficient as that, but the concept is very similar to data dumps out of a system, scrubbing it, and then putting it back in. Obviously, that's another system that you have to build and maintain, but I think that it's absolutely imperative as a development crew that you do that as much as possible, because again, if you're testing, I didn't really emphasize enough, but your testing suite that you build is your safety net. It is the one thing that keeps the higher ups from coming back and saying, all right, let's make a gold build and stop all production development until this is done. Once you've done that, you've lost all the credibility and all of your goodwill. So you need to keep your testing frameworks up to date. So if it is hourly dumps and you're doing some sort of redaction from that yourself, or if you're using something like DLP, that's usually what I would end up looking at. I don't really, there are some systems that probably exist, but I don't know them all that well. Oh, and that last one was me testing this. All right, so I think that's all I have from the testing. So I think I'll be here around for a little bit longer here if you guys want to swing by and ask questions. We will get these out. Again, find LinkedIn, find Nortal on LinkedIn. On behalf of the recruiting team as well, we are looking for cloud developers. We are coming into this market with some of the stuff that we've built from the US, and we are trying to build a pretty strong presence here. And likewise, we're trying to build a pretty strong community. So I want to thank you guys all for coming here. Hopefully we can get you guys on a stage here and present some of your solutions as well. Having a strong community and building this, this is kind of some next level stuff that's out there. I want to know what the next one is after that. Start seeing some serverless type stuff, start seeing some, other solutions that are built out. And that's really only built if we have a strong community and we can bounce ideas off of each other. So thank you guys very much, and enjoy your beer.